Today, we're digging into the invisible architecture that, and I mean this literally, holds you together. It's the body's ultimate construction material, hidden in plain sight right between every single one of your cells. I mean, really think about that for a second. Your body is made up of trillions of individual cells. So what's stopping you from being just a disorganized, wobbly puddle on the floor? What gives you your shape, your strength, your actual structure? Well, the answer is something called the extracellular matrix, or the ECM for short. It's this incredibly complex 3D web of proteins and sugars that your own cells pump out, filling all the gaps between them. But it's not just filler. Not at all. It's the stuff that turns a simple pile of cells into a working tissue. Now, it's really easy to just think of the ECM as, biological glue. But as we're about to see, it is so much more than that. It's an active, dynamic, and absolutely essential system. Okay, to really wrap your head around this, let's think of it like this. Your body is a massive, incredibly complex skyscraper that's always under construction. And your cells, they're the bricks. They're vital for sure, but on their own, they're just a pile of bricks. You can't build a skyscraper with just bricks. The ECM is basically the entire construction site. It's the steel scaffolding that provides support. It's the special concrete mix that decides if a wall is going to be rock solid or flexible. It even lays down the highways that cells use to travel. It acts as a supply depot holding on to critical molecules. And, this is huge, it serves as the communication line, passing messages from the outside world directly to the cells. And the amazing part is how versatile this stuff is. Using the same basic building blocks, the ECM creates wildly different materials. In your bones, it's mixed with calcium to become as hard as a rock. But in your cartilage, it's this spongy, shock-absorbing gel. And in the cornea of your eye, it's arranged so perfectly that it becomes crystal clear. So who's actually on this microscopic construction crew? Let's meet the key proteins, the molecular workers that are responsible for building you from the ground up. We can basically break down the crew into three main gigs. First up, you've got collagen. Think of these as the steel support beams of the body. It's actually our most abundant protein, and it provides incredible strength. Then you have the proteoglycans. These guys are like hydrated sponges, forming a gel that cushions everything and resists squishing. And finally, you've got the multi-adhesive proteins. These are your site foremen, the ones connecting the cells to the matrix and telling them where to go. And just to give you a sense of the sheer complexity here, we're not just talking about one kind of steel beam. No way. Scientists have identified at least 28 different types of collagen. Each one is a specialized tool perfectly designed for a different job in a different part of the body. And here's the kicker, the really important part. This construction site is never finished. It's a living, breathing system. The ECM is constantly being built, torn down, and reshaped. And this whole dynamic process is essential for, well, pretty much everything, from how we develop as a fetus to how a simple paper cut heals. But as you can imagine, this constant remodeling is a really delicate dance. So what happens when the construction process goes haywire? What happens when the very structure that supports us starts to crumble or build in the wrong way? Well, when that balance of building and demolishing gets thrown off, you get disease. Fibrosis is a perfect example. This is what happens when the cells just start making way too much ECM. It's like the construction crew just starts pouring concrete everywhere. The tissue gets stiff and scarred, and that can lead to total organ failure in places like your liver or your lungs. And the matrix can play a really sinister role in cancer too. For one, it can become so dense that it actually forms a physical barrier, blocking chemo drugs from even reaching the tumor. It can also change to create these stiff superhighways that cancer cells use to escape and spread. And worst of all, little fragments of the broken down matrix can actually send signals that tell tumors to grow even faster. Okay, so that's the scary part, but it's not all bad news. In fact, by understanding the ECM's blueprint, scientists are figuring out how to use it to heal us. And this is where the story gets really exciting. This is really the foundation of what we call regenerative medicine. The core idea is brilliantly simple. Instead of trying to invent new materials from scratch, why not just use the perfect blueprint that nature has already designed? The ECM itself provides the ideal template for rebuilding parts of our bodies. The process itself is just incredible. Scientists can take a donor organ, say from a pig, and use special detergents to gently wash away all the original cells. And what's left behind is this ghostly white scaffold made of pure ECM. It's the building's original blueprint, completely intact. They can then take that natural scaffold and seed it with a patient's own cells, which then recognize their old home and get to work growing new functional tissue. And listen, this is not science fiction. This technology is already being used to create advanced skin grafts for burn victims and to make medical implants more compatible with our bodies. Right now, researchers are using it to regenerate cartilage and to lay the groundwork for the Holy Grail, growing entire complex organs in the lab. So let's just zoom out. The extracellular matrix is so much more than some passive stuffing between our cells. It's an active, it's a dynamic, and you could even say it's a profoundly intelligent system. It's the architect, it's the building material, and it's the communication network all rolled into one, guiding the story of our bodies from the day we're born. And that brings us to one last really powerful thought. We are just now beginning to learn how to read and write in the language of this fundamental blueprint. As our ability to work with the matrix grows, the possibilities become almost limitless. So the only real question left is, what are we going to choose to build next?